Exercise 8.1. A car accelerates uniformly from rest for 30 seconds. Its speed after 30 seconds is 18 meter per second. The speed remains constant for the next 10 seconds. Draw the speed time graph for the first 40 seconds of the journey. Now we have to draw the graph for the 40 seconds, and the breakup is there that the car accelerates uniformly from rest to rest for 30 seconds. So 30 seconds is here, and the speed is 18 meter. So 30 seconds and 18 is here, and it start uniformly mean and start from rest from 0, and uniformly mean a straight line we have to draw. Now this is the line, the straight line which shows the slope between the speed time graph, and this reveals that it is a acceleration. Whenever a line is drawn between in the graph of a speed time graph, a straight line is given, the slope is called acceleration. So it accelerates from rest, so straight from 0 and up to 18 meter per second till 30 seconds. So and then the next 10 seconds its speed remain constant. Not the 10 second, after the 10 second or 30 to 40 second the speed is constant. So its speed is 18 meter per second. This is the line. So we have drawn this basically the graph, and now we are asked to calculate the car acceleration during the first 30 seconds. Now the acceleration, whenever a graph is given, it is a speed time graph, so the slope of finding any line is called acceleration, and we have to find the acceleration for the first 30 seconds. So we have to take 2 points here, and we have to find slope or the gradient. So here it is 30 and 18, x-axis is 30 and y is 18, and it is 0 0. So we take slope, so we find the solution. So slope or gradient, we say gradient is m, and y2 is 18 minus y1 is 0 upon x2 is 30 and x1 is 0. So it is 18 upon 30, and when we use calculator, so we find that 18 divided by 30 is equal to 0.6. So it is 0.6 meter per second square. Acceleration is 0.6 meter per second square. Now in part 2, its average speed for the first 40 seconds. So average speed, first we have to find the total area it cover when time is 40 seconds. So solution is there. So distance it traveled in 40 seconds. So in speed time graph, the area under the graph is the total distance. So the area of this diagram is the distance. So this is we can see that it is a trapezium. The two lines are parallel, these two lines are parallel, and these two lines are not parallel. So it is a trapezium. So we find the area of trapezium, which shows that how much distance it travel. In speed time graph, the area under the curve or area under the area of the diagram, you can say, is the distance. So area of the diagram is a trapezium, so we find the area of trapezium. So area of trapezium is 1 upon 2 L1 plus L2 multiplied by height. Height is basically the 90 degree between the two parallel lines. It is a parallel line and it is parallel line, and the distance is height is 40 seconds. So area would be 1 upon 2 length 1 L1, the two parallel line, L1 and L2 is two parallel lines. So we suppose it is L1 and this length is L2. So L1 is 30 to 40 is 10, it is 10, the length is 10, and plus L2, the length is 40, this is the L2 and its length is 40, and its height is the distance between the two parallel line is 18. It is 18 basically, height is 18. So we solve this 1 upon 2, it is 50 and it is 18. So 2 ones are 2, 2 nines are 18 and 9 0 0, 450 meters. It is the total distance, and now we have to find the average speed. So average speed is equal to total distance upon total time. So total distance is 450 and divided by total time is 40. So we calculated 5 8s are 40 and 5 9s are 45 and 0 further we divide 2 4s are 8, 2 4s are 8, 2 5s are 10, and it is, when we divide this through, use the calculator, so it is 45 divided by 4 is 11.25 meter per second. The average speed is in second. Actually it is paper 1, calculator is not allowed, but if you leave it up to 45 upon 4 meter per second, it also works. So no, do not need to go for a long calculation. You can solve this or leave the answer up to this.